Alright, hello everyone and welcome back to our last lesson in this chapter. Today we will be talking about rationalizing the denominator. Before we start the lesson, please make sure that you support the video by liking the video, by subscribing to this YouTube channel so that you can also see all previous videos and all future videos that are related to this topic. Also, do not forget to check the description box where I have shared PDFs with lots of practice questions together with answer keys for them. Alright, rationalize a denominator. Now, what does that mean? First of all, before we start with this, rationalizing the denominator, I just have a quick question for you. This is something that we did last week. So, if we say, for example, square root of 5 multiplied by square root of 5, that is equal to square root of 5 multiplied by 5, 25. Oh, but this is basically equal to 5, right? So also, if we multiply whatever, let's say square root of 11 multiplied by radical 11, it will be, again, keep in mind, square root of 121, but this is basically equal to 11. So we do not have to write it again, right? Or if we have, for example, 5 radical 2 multiplied by 2 radical 2. Keep in mind that we multiply number by number. So 5 multiplied by 2 is 10. But then we have radical 2 by radical 2. That is equal to radical 4, which is basically equal to 2. So 10 multiplied by 2 is 20. Alright guys, so square root of, let's say square root of 7 multiplied by square root of 7 is equal to 7, because that's equal to square root of 49, but we know that that is 7. So if I tell you square root of 18 multiplied by square root of 18, we know that that is equal to 18. So square root of 18 by square root of 18 is equal to 18. Okay, there is one more thing I wanted to revise before we start with the lesson. If we say, for example, 1 minus radical 5 and we multiply that by 1 plus radical 5. We learned last time that we multiply 1 by 1, which is 1, 1 by radical 5, which is radical 5. Radical 5 by 1, which is radical 5, and radical 5 multiplied by radical 5, we said it's 5, right? Oh, but what do we have? Positive radical 5, negative radical 5, they will cancel each other out. So we have only 1 minus 5, which is equal to negative 4. Okay, I hope that this was clear. If not, please refer to the previous lesson where we have explained all of this. Now, in today's lesson, if we have a fraction, for example, 5 over radical 2, this has to be rationalized. Now, by rationalized, we mean we do not want to see square roots in denominator. How do we get rid of that? You know, according to what we just explained, that radical 2 multiplied by radical 2 will give us 2, right? But if you multiply your denominator by radical 2, you must multiply your numerator as well. So what does it become then? 5 radical 2, 5 multiplied by radical 2 is 5 radical 2. What do we have in our denominator? Radical 2 multiplied by radical 2 is radical 4, right? But what is radical 4 equal to? It's equal to 2. That's how we get rid of the radical in denominator. So let's try another example. If we say 1 over radical 11, okay? So what do we say here? To get rid of radical 11, we multiply by radical 11 and we multiply by radical 11. Now, what do we get by multiplying by that? 1 multiplied by radical 11, radical 11. Radical 11 by radical 11, 11. That's it, we are done. So this, what we have just done, is what we call rationalize the denominator. If you want, we can do another example. Let's say 6 over radical, let's say 18. Okay, what do we do over here? 6 radical 18. We multiply this, both numerator and denominator, by radical 18. Why is that? What do we get by doing that? We get 6 multiplied by radical 18, 6 radical 18. Radical 18 by radical 18, 18. Oh, excellent. We do not have square root in denominator anymore. Okay. Now, can we multiply, for example, 6 and 18? Yes, we can divide them by 6, right? So that becomes square root of 18 over 3, because we divide them both by 6, and we get square root of 18 over 3. This can be simplified further, but we will talk about that soon. So the idea is we do not want to have a radical in denominator, so we multiply by whatever the radical is. Okay, what if we have 7 over 5 radical 2? Okay, what do we want to get rid of here? Of radical 2, of square root of 2. So you multiply this by, we multiply this by square root of 2, and we multiply this by square root of 2. Okay, what does it become then? 7 multiplied by square root of 2, 7 square root of 2. 5 square root of 2 multiplied by square root of 2. That is equal to 5, and then square root of 2 is 2, right? So we have 7 radical 2 over 5 times 2 is 10. Done. So the only one that we wanted to get rid of is radical 2. To get rid of radical 2, we multiply by radical 2 our numerator and denominator. So now we have 7 radical 2 over 10. We have radical in numerator, but that's okay, we don't care about that. So radical in the numerator is allowed. There is no problem with that. Alright, let's have one more example. 3 over 2 minus radical 5. This time we have 2 different terms in denominator. The only way to get rid of this is by multiplying both numerator and denominator by something that is called radical conjugate. Radical conjugate. What is radical conjugate? Basically, we just copy this, but we change the sign. So if it was positive, we multiply that by a negative value. If it was negative, we multiply by a positive value. Okay, let us perform. But if we multiply denominator, you know that you must multiply the numerator as well. Alright, what do we get here? 3 multiplied by 2 is 6. 3 multiplied by radical 5. So you know we multiply by the first one, by the second one. 3 multiplied by radical 5 is 3 radical 5. Now denominator. It's better if you put this in brackets. 2 multiplied by 2 is 4. 2 multiplied by positive radical 5 is 2 radical 5. Negative radical 5 by 2, negative 2 radical 5, and negative radical 5 by radical 5 is negative, and then radical 5 multiplied by radical 5 is 5. Alright, what do we have over here? Our numerator, 6 plus 3 radical 5. Our denominator, positive 2 radical 5, negative 2 radical 5, positive 2, negative 2, they cancel each other out. 4 minus 5 is equal to minus 1. That's it, we are done. If you want, you can simplify this further and just put minus in front. So you say this is minus and then 6 plus 3 radical 5, but this one is also correct. So one more time, what's the idea? If you have two terms in denominator, the only thing you have to do is to multiply both numerator and denominator by the same thing with opposite sign, because we call it radical conjugate. Now, if this was clear, let us try some of the examples from this one. So, what do we have for the first one? 1 over radical 3. What would we multiply this? Radical 3 over radical 3, right? So, 1 over radical 3. What did we say? 1 over radical 3. You would multiply this by radical 3 and you would multiply this by radical 3. 1 multiplied by radical 3 is radical 3. Radical 3 by radical 3 is 3. Done. We are done with the first question. Alright, now we have another one. 2 over radical 6 plus 2. We said whatever we have in the denominator, we multiply that by the same thing up and down, this time with the opposite sign. Radical 6 minus 2 and radical 6 minus 2. Alright, so what do we get over here? 2 multiplied by radical 6, 2 radical 6. 2 multiplied by 2 will be 4 over radical 6 by radical 6 is 6. Radical 6 by minus 2 minus 2 radical 6. Then we have 2 multiplied by radical 6 is plus 2 radical 6. And finally 2 multiplied by minus 2 is minus 4. Now this is something that we know already, right? 2 radical 6 minus 4, and then in denominator negative 2, positive 2, they cancel each other out. 6 minus 4 is equal to 2. The only thing we can do is divide everything by 2 if we want to simplify that, right? So we can divide everything by 2. So what do we get? 2 divided by 2, radical 6. 4 divided by 2 is 2. 2 divided by 2 is 1. Alright. Okay, then we have another one. It's getting more and more difficult, as we can see. So, 1 over 4 radical 2 minus 3 radical 3. So, as we said, we multiply by the opposite sign of the same thing. 4 radical 2 plus 3 radical 3. 4 radical 2 plus 3 radical 3. Okay, if we multiply them now, the numerator 1 multiplied by this is 4 square root of 2. 1 multiplied by this is 3 square root of 3. Then we have our denominator. 4 radical 2 multiplied by 4 radical 2. 4 times 4, 16. Radical 2 by radical 2 is 2. Now guys, listen to this. If we have 4 radical 2 multiplied by positive 3 radical 3, and then I have negative 3 radical 3 multiplied by 4 radical 2, they will cancel each other out. Let me write it down so that you can see what I'm talking about. Okay, so first step done. Now second step, this one multiplied by this one. 4 multiplied by 3 is 12. Radical 2 by radical 3 is radical 6. Right? Now we multiply the second one. So 3 radical 3 multiplied by 4 radical 2 is 12 radical 6. And finally 3 radical 3 multiplied by 3 radical 3 is 3 times 3, 9. Radical 3 multiplied by radical 3 is 3. Alright, so something that difficult will actually be something easy. What do we have now? In the numerator, 4 radical 2 plus 3 radical 3, while in the denominator we said positive 12 radical 6 and negative 12 radical 6, they will cancel each other out. So we have 16 multiplied by 2 is 32. 9 multiplied by 3 is 27. Excellent, which means 4 square root of 2, 3 square root of 3 over 5. With that, we are done with this question. So it looked very difficult, very complicated, but it is actually not. I hope that it was clear. All right, and the last one for today. What do we have over here? Square root of 11 plus square root of 5 over square root of 11 minus square root of 5. So we said we multiply by whatever is in our denominator, but with opposite sign. So it's going to be square root of 11 plus square root of 5. Square root of 11 plus square root of 5. So we multiply everything by everything, right? Here we can put this in brackets to make it easier. Square root of 11 multiplied by square root of 11 is 11. Square root of 11 multiplied by square root of 5 is square root of 55. Square root of 5 multiplied by square root of 11, square root of 55. Square root of 5 multiplied by square root of 5 is 25. Excellent, we do it in denominator as well. Square root of 11 multiplied by square root of 11 is 11. Square root of 11 multiplied by square root of 5 is positive square root of 55. Then we have negative square root of 5 multiplied by square root of 11 is negative square root of 55, and square root of 5 by square root of 5 is negative 5. Excellent. What do we have in the final step? In the numerator we have 11 and then we add to 25, that is equal to 36. Then we have square root of 55 and one more time square root of 55, so it means we have 2 square roots of 55. In our denominator, do we notice that we have positive square root of 55 and negative square root of 55, so they cancel each other out. Finally, 11 minus 5 is equal to 6. With this we are done. Even though you can do one extra step, simplify everything by 2. So 36 divided by 2 will be 18. 2 divided by 2, 2 goes away. And 6 divided by 2 is 3. Alright. So guys, I know it was a difficult lesson. Please make sure that you watch this video many times. But what's most important, just remember, if we have one number down, you multiply them both by the same radical. If we have a radical and a number down, you multiply again only by the radical to get rid of it. Okay? If you have a number and then, for example, 2 minus radical 3, you multiply that by 2 plus radical 3, 2 plus radical 3. And finally, if you have whatever, let's say radical 3 minus radical 11, and then here we have radical 8 plus radical 15. Again, we multiply this by whatever is in the denominator. Radical 8 minus radical 15, radical 8 minus radical 15, because positive is opposite to negative. Okay, that was the summary of today's lesson. Any questions, make sure that you write this in the description, in the comment, and check the description box with practice questions and answer keys combined. That is it, guys. Subscribe to the video, and I will see you in the next video and the new chapter.